Our goal for this section is to put radical expressions in terms of smaller or simpler radical expressions. To do so, we're going to need two properties. And the properties basically say that if I have A times B, I can split it into two pieces. So basically split the radical into two. Or if I have A over B under the radical, I can split it into two different radicals. And again, this only applies to multiplication and division, not addition or subtraction. So if I have nth root of A plus or minus B, that does not equal the nth root of A plus or minus the nth root of B. So this is a big no-no. Right here does not apply. If I have multiplication or division, it does apply and I can split them into two separate pieces. I also want you guys to know that you can go in both directions. You can start with 1 and put it in two separate pieces, or you could start with 2 and go back to 1. So you could go in this direction, split it, or start with the 2 and put it back into one radical squished together. Let's look at some examples applying these two properties. So if I have two radicals multiplied, they're both square roots, I'm going to squish them into one, and that's going to be square root of 9, which we know will pop out a 3. Again, I have multiply two square roots, so that's going to be square root of 2 times 18, and square root of 2 times 18 is 36, which we know pops out a 6 because I have two 6's under the radical or the square root. Now I have multiplied two radicals. I'm going to put them together. A half times an eighth. That's going to give me 1 times 1 is 1. 2 times 8 is 16. And now I can split it using the second property into a top and a bottom. The top pops out a 1. The bottom pops out a 4. So ultimately I get 1/4. Here I have a division. I'm going to split it into two pieces. Square root of 25 over square root of 49. Top pops out a 5. Bottom pops out a 7. And we're done. Same thing here, but it's a cube root. Pay attention, it's a cube root. So I'm going to split it. Cube root of x cubed over cube root of 8. Well, I have three x's underneath. I have x times x times x, and for the 8 I have 2 times 2 times 2. And remember, because it's a cube root, for every 3 identical multiplied, 1 pops out. And again, because it's a cube root, for every 3 identical multiplied, 1 pops out, so our answer is x over 2. Let's look at a couple more. I have a division of two square roots, so I'm going to merge these and put them under the same radical, 45 over 5. So I'm doing the opposite of what I did here. Here I split it. Here I'm going to merge them back together. And when I do that, notice I can simplify. 5 into 5 once, 5 into 45 9 times. That makes the problem much simpler. Now I have square root of 9 over 1, which just pops out a 3 over 1, so we're good to go. Same thing for part B. We're going to merge the two together under the same big radical. A squared over B all over A, it looks like. That's going to give me A's go away. So I have this A disappears with one of these A's, and I end up with square root of 1A on top, 1B on top, only a 1 in the bottom, so I don't need to put it there. And since I don't have enough of A or B, there's nothing more I can do. This is the best that I can do. Both A and B are basically trapped under the radical. Part H, simplify. Again, I have things multiplied, so I can split them using the property. I have cube root of 8, cube root of x, cube root of y cubed. This one pops out a 2. This one is stuck because I only have one x trapped. And this one again pops out a y because I have the 3 y's that I need. I have y, 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 and since it's a cube root, 1, 3 pops out. Just like here I have 2, 2, 2 multiplied, and because it's a cube root, only 1, 2 pops out. So my final answer looks like it's just going to be 2 cube root of xy, or often you put the y, the ones that's popped out of the radical, and you put the radical last. Either one is okay. Part I, again I have 3 things multiplied, so I'm going to split them up. I have square root of 16, square root of x to the 4th, square root of y to the 6th. We know this one is going to pop out a 4. For the second one, I need 2 identical items multiplied, so it looks like I have x squared and x squared, and for every 2, because it's a square root, 1 pops out. And then for the last one, I can think of it as a y squared, or better yet, actually, a y cubed times a y cubed, so that I have a repetition of 2 identical items, and for a square root, one of them pops out. So my final answer is 4x squared y cubed if it said assume all variables positive. Then I would be done. If we don't know if variables are positive, then we would say 4 x squared is a positive quantity anyway because of the square. The y cubed, we would put in absolute value bars to make sure it stays positive. Like we said earlier, if we don't know anything about the variables being positive, we have to have bars around the variables. And again, x squared is always positive anyway, because when you square an item, it gives you a positive number. So most likely you're going to see this. You're probably going to see that it says assume all variables are positive, and then your answer will be the first answer, which is this one right here. The next thing we want to tackle is simplifying radicals to put them in terms of those smaller radicals I was talking about. So there's 2 methods we can do this with. Here are the 2 methods. Either put the radicand, this number inside, in terms of perfect squares or perfect cubes or whatever the index is, and then split the radicals and simplify, or create repetitions, that's the other key, and pop out the numbers that get out of the radical. So here is what I'm talking about. Way 1 would be, okay, I'm going to break up 50 as 25 times 2. Once I have 25 times 2, once I have 25 times 2, I'm going to split it, and that's going to be square root of 25 times square root of 2. And we know this pops out a nice 5, and this one is stuck basically because it's not a perfect square. So that would be method 1. Method 2 would be take 50 and do, let's say, like 5 times 10, if you want to start with 5 times 10. Since you don't have perfect squares, you break up 10 even further and you say that's going to be another 5 times 2. Now you have repetition. You have the 5 repeated twice, and these 2 get together and 1 escapes the radical because the index is at 2. So when 1 escapes, 5 comes out, and this guy is stuck because it doesn't have repetition, so my answer is still 5 square root of 2. So 2 options, slightly different. It doesn't matter which way you do to simplify it. And what we did was we put square root of 50 in terms of smaller radicals, which is in terms of radical 2. Alright, let's simplify these. So I take 200, and maybe the first 2 numbers that popped up in your head are hey, that's 2 times 100. And then this 100 I like because it pops out a perfect 10 if I split it. So once you like the number, put a check and say, hey, I'm going to split it into 2 pieces. This one is stuck because it's not a perfect square. This one pops out a 10 because square root of 100 is 10. And since these are a product, normally you put the one that popped out first and then the radical after it. Let's say we're looking at 72. Maybe you thought of 72 as, let's say, 8 times 9 is 72. This one is a good number, so I'm going to split it as far as square roots are concerned. So square root of 8 times square root of 9. This one pops out a 3, so we're good to go. Whereas square root of 8 can be simplified further. So what I'm going to do now is I'm going to put the 3 outside and it's going to wait, and then I'm going to analyze square root of 8. Well, square root of 8, I can break up 8 as a 4 times 2. And then 4 is a good number because it's got a perfect square, so I'm going to split it up into 2 pieces, and this guy is going to pop out a 2, and this guy is just stuck as it is because it doesn't have a perfect square inside. Now pay attention because you had saved the 3 that was waiting, and whatever pops out gets multiplied with whatever was waiting. So our answer is going to be 3 times 2, which is 6, square root of 2. Now you might have thought originally to think of 72 as, maybe you thought, or what about if I do this? 72 is just 36 times 2. 36 times 2 gives me 72. Now split it into 2 pieces. This one pops out a 6, this one is stuck, and I get 6 radical 2 much quicker than I did this way. It doesn't matter how you get there as long as you slowly show all your work and you get an accurate answer. Now let's look at a cube root. So I'm going to need repetitions of 3. You might think of 54 as, let's say, 9 times 6. If I think of it as 9 times 6, it's a cube root, so I can't take a 9 out as a 3 because it's a cube root. So I'm going to split this further, I'm going to split this further, and I'm going to say 9 is 3 times 3, and 6 is 3 times 2. And now we're talking because I have 1, 2, 3 3's, and I'm looking at a cube root, so these 3 get together and 1 escapes the cube root. So my answer is going to be 3 escape outside, this guy is stuck, and that's going to give me cube root of 2 stuck with a 3 coming outside. Again, let's look at another cube root. So for cube root of 32, we're just going to break 32 up as maybe like 4 times 8. And then this 8 is actually a perfect cube. If I split it into 2 separate ones, this is going to escape as a 2, and this one is stuck because I only have 2 2's. So my final answer will be a 2 outside and a cube root of 4 left in the answer. Or maybe you said, hey, I'm going to break up the 4 and I'm going to break up the 8 further. So that would be 4 is 2 times 2, and 8 is 2 times 2 times 2. And now you have repetition of 2's, and these guys get stuck and escape, and the other 2 2's are stuck inside. So this 2 leaves, these guys are stuck because there's only 2 of them and you're looking at a cube root. So ultimately you have 2 outside, cube root of 4, which is the same as this guy.